All right. Let's see, is everyone here? All the panel members here? Wait, no, we're missing. Okay, you're sitting down. Yep. That's everybody. Yeah. Okay. All right. I'd like to welcome everyone back. Hope everyone had a great lunch. We're going to continue in the afternoon with the mechanistic studies, discussion of those. So I'd like to start with Patrick Allard.
Yeah, thank you. I guess before I get into those studies themselves, I'd like to mention how I approached my job as part of this committee, and the function or the place that those mechanistic studies occupy. So my framework here was to look at those studies to try to extract biological plausibility, and basically act as support to the animal studies and the human studies as well, and try to articulate the evidence that was presented in the HID as well as, of course, what's in the literature, not just in terms of the key characteristics, which is a great framework to use, but also more or less build your own adverse outcome pathway with regards to several of the endpoints that were shown in animals. And then I personally try to rank the sets of evidence with different degrees of certainty, from no effect to supportive, convincing, or clear. And then I'm probably going to say something controversial, which is that for me, the dose, this is like sacrosanct toxicology, but for me, the dose was not something that I initially put at the forefront. I took it into account, but there were several issues there in terms of trying to parse out the studies and try to really look at the dose. The first one is that most of the studies did not actually do enough dose responses for us to come up with a point of departure or low L and no L. Even the in vitro studies did not have enough of those to try to figure out exactly the dynamics of the dose response and any of those key metrics. And then also the fact that, I feel like I say that every year, but we're more on the hazard side than on the full risk assessment side of things here, which is not, to me, the goal of the job here, what we're being asked for. So I did use the key characteristics framework, though, and then try to layer out some adverse outcome pathway onto it and figure out the molecular initiating events that could be behind some of those effects. But I'll go through some of the key characteristics components that I thought were quite telling. And so the first key characteristics that's listed, which is alteration in germ cell development, function, or death, I found that the evidence overall was convincing, and that overlaps quite extensively with the animal studies, especially with regards to the sperm parameters, which over many studies show a decrease in sperm number and sperm morphology as well. And one of the studies, for example, that spoke to me the most, or the data was the strongest, is the Diet al paper from 2021 that reported a dose-dependent significant decrease in sperm count and sperm motility, down to 40% or decreasing 40% at the highest dose that was tested. And I did note about the doses that what I thought was interesting in that study is that the doses that they tested overlapped with the BASF doses that had been tested by the registrant. So I trusted that the registrant would test doses that would be relevant. And so I like the fact that there was overlap in the doses there. And these were adult studies, I should say. And this was replicated in another adult male study as well, the Sawu and Verma from 2023. One thing that made me lean towards a convincing impact on germ cell germ cell development, function, or death, and the sperm parameters is the fact that many of the sperm parameters showed up in a variety of species that are evolutionarily quite distant in some cases, So, mouse, rat, of course, studies, but also hamster studies and zebrafish studies all reporting the same kind of endpoints. I do want to note that some studies did not report an impact on sperm. Did not see an effect on sperm parameters, or the magnitude was not as strong. But these came from the series of study from Ula et al. And Fankloka, I think it is, which is the lactational study. But I do want to know that, as actually reported in the HID, there were some issues in those studies with regards to the proper staging of different stages of spermatogenesis, and also in the, if I'm correct, in the lactational studies, there were also issues with positive control, sometimes the positive control not being actually positive. And so I leaned less on those studies, and those studies tended to be not showing an effect on sperm parameters. So overall, for that first key characteristics, the data was very convincing. The second set, and those things actually paired also with alterations in morphology of the seminiferous tubules, which goes under KC2 as well, the somatic component of the seminiferous tubules were also impacted. The third key characteristics, which is altered production of reproductive hormones, also quite convincing to me because of consistency across different types of approaches, from in vivo to ex vivo, or what is listed under in vitro, but it's explant. So for me, it's sort of an in-between sort of situation, where quite consistently, and this is done in mice, rats, and zebrafish, there's an increase in estradiol, and that's different actually from the human studies, at least some of the human studies, and so we have to think about that. But at least across all these different studies in animal models, there's an increase in estradiol, and then also consistent decrease in testosterone that also, I believe, dose responsive and paired up with changes in the level of expression of the enzyme, the steroid hormone pathway enzymes that are responsible for the production of those hormones. So the two sets of data fit with each other, and again, quite consistent across things. Now, I think it's important to mention that there seems to be an effect of BPS on the levels of steroid hormones, but BPS itself is hormone mimicking. It's an endocrine disrupting chemical. And that direct effect of BPS as a steroid hormone mimicking chemical was tested in the spermatocyte cell line GC2. And they did see basically what you expect out of BPS, which is that it acts as a xenoestrogen. And you see that several, and so I'm referring here to a specific study by, I don't know if I'm going to be able to pronounce it, Sidorkiewicz et al. From 2018, where they saw basically that the estrogen responsive genes are upregulated both in the positive control with estrogen as well as BPS, and they tested all the bisphenols. And BPS was weaker than the other bisphenols, including bisphenol A, but it did show significant increase in these estrogen responsive genes, showing that direct impact of BPS as an endocrine disruptor itself. And this is, all of it is supported also by the in vitro data from the NTP, the 2017 NTP report on BPA analogs, that looked at BPA's in vitro collection of assays and the in vitro activity that was mostly, actually uniquely for BPS as an agonist of the estrogen receptor. Although again, it's weaker than almost any of the other bisphenols. Something that was mentioned at the end of the HID, but I thought was really interesting because for me that fits in the same kind of pathway, is the fact that BPS can actually bind STAR, which is the one of the factors that can actually help move cholesterol and actually jumpstart the steroidogenic pathway. And I thought that was really interesting because BPA can actually work at the level of STAR too. And so seeing this parallel between BPA and BPS, and the fact that BPS could, that's a potential pathway here, but BPA could alter the synthesis of hormones by altering right from the get-go the activity of STAR or bind to STAR and therefore potentially compete with other with cholesterol, to me is very interesting. And all of this also fits with the fact that in several studies, BPS decrease the anal genital distance in mice and rat studies. There's some inconsistency there, but it's sort of, again, aligned to me in an adverse outcome pathway. Okay, so there's other key characteristics. I'm going to try maybe to speed up a little bit. In terms of key characteristics 5, genotoxicity for me was not as convincing, but the data was supportive of an impact of BPS as a genotoxic agent. And maybe I'll fuse that with KC7, which is oxidative stress. It is, when looking at the collection of evidence, it looks like one mechanism for its genotoxicity is actually by the generation of reactive oxygen species. Which increases, for example, markers of oxidative stress and oxidation of DNA. And so one marker of that is 8-hydroxy-2-deoxyguanosine. And there is, across different studies, an increase in that mark of oxidative stress on DNA. There's also quite a few studies that showed an increase in breakage of the DNA through the COMET assay. But one thing that I noted is that a lot of these studies actually came from the same group. It's the Ula et al. Series of papers on BPS. And I personally, I would have liked to see repetition across different laboratories. So this is why it sort of downgraded the genotoxicity data from convincing to just supportive. Right, and so oxidative stress, there's a lot of evidence regarding BPS causing oxidative stress, both in vivo, ex vivo as well. It's seen at the DNA level, at the lipid peroxidation level, and it's also associated with quite significant modulation of the oxidative stress response genes. And there's mechanisms behind it. So when you look at the impact of BPS on the mitochondria, and this is actually where I'm going to end. I think this is where I'm going to end. I have many pages. We can actually see a cause or an effect of BPS on mitochondrial function. And so, for example, several studies have described an impact of BPS on mitochondrial depolarization, an increase in mitochondrial permeability. And this is both in Leydig cells as well as the spermatocyte cell line GC2, and at a wide range of doses as well. So that ability for BPS, you could build an AOP here with BPS disrupting mitochondrial function, causing oxidative stress, which could lead to DNA damage and likely a dysfunction of the cells. There's one KC, I just gotta make one comment about a KC that I did not actually lean on, surprisingly, since I'm an epigeneticist as well, is that KC6 epigenetic alteration. And the reason was that I think, we're limited with the data that exists, of course, but I think one way to really leverage epigenetic data and molecular data is actually try to integrate epigenetic data and gene expression data into gene ontology analyses to see whether the pathways that are triggered align with the endpoints, like the histological endpoints that have been detected. And the studies didn't really support that. There's one Medaka paper that actually did a pretty good job, but overall there was not much there. And I think in the future, when the paper is actually available, instead of looking at epigenetic enzymes going up and down, which to me is intriguing, but but not really interpretable that much. It'd be better to look at the gene expression data sets and the epigenetic data sets and try to, again, use gene ontology as a way to sort of extract significance out of all these epigenetic changes and gene expression changes that happen when cells are exposed to a chemical. So overall, across all the cases that to me were quite telling, the data overall was quite convincing of an impact of BPS on many of the male KC characteristics for reproductive toxicants. And that concludes my comments.
Much, Patrick. Do we have any questions for Patrick, or otherwise we will move on to our next presenter? All right. So last but not least, Isaac.
I'll make this very short. Thank you, Dr. Allard. That was really very succinct review. Clearly, mode of action is different from mechanism of action, but it's all part of this adverse outcome pathway. You need to put the pieces in and try to generate cause and effect in our understanding. Where I started was with what's the occurrence of BPS in human serum, and I used the studies that were actually presented by OEHA, and I used the 90th percentile so that I didn't sort of skew my viewpoint. And then I also looked at serum binding, and most of BPS is serum bound. It's 90% plus serum bound. So you have to ask, what's the free concentration? Clearly, there are diurnal fluctuations with drinking or exposure. There are temporal variations that we don't have a handle on. So with that, but if you take the 90th percentile and ask, well, what is the free concentration of BPS in the human body? It's anywhere between 0.2 and 1 nanomolar. So in doing that, and I'm focusing now on mechanism of action, not mode of action. Clearly, there are all the cases you can find mode of action. Things change when exposures occur. And it would take a very complicated table to try to assess where do you put the cutoff, that these are not reliable studies because they're 4 or 5 orders of magnitude above human exposure, internal exposure. And in some of these ex vivo experiments, never measured. So you don't know what the actual exposure led to in terms of internal exposure. So if I looked at the most sensitive studies, clearly some of the stereogenic hormones are changed at very low levels of exposure, whether they're ex vivo measurements or in vitro exposures. But none of them really get close to that 0.1, 0.2 nanomolar concentration range. So then I asked the question, what's known about mechanism of action? Does BPS bind to a steroidal receptor? What is the evidence? And if there is evidence, what's the affinity? And I really couldn't find, maybe STAR was one of them, but then I was asking myself, how does BPS compete with cholesterol at that STAR receptor? And I know cholesterol probably binds with 10 to the minus 10 affinity, so it has to be at a pretty high concentration to begin to alter that signaling system. And that may be very sort of naive way of looking at it, but when you're asked to look at mechanisms, you have to focus in on what are the molecular steps that lead to all of these sort of outcomes that are listed under mechanisms of action. So with that, I don't think we know what the mechanism of action is. There are probably multiple mechanism of actions. One of the things that I found really intriguing was this inverse U-shaped dose response, where you see an effect at really low doses, it shuts off at slightly higher doses, and then it goes in the other direction. And that could really be a really good basis for future studies where you're trying to limit exposure levels to those where you're in that part of the dose response, which is actually an inverse dose response. That may get us more to what are the key mechanisms that begin these cascades of effects that lead to hormonal changes, motility changes, developmental changes, and they're probably not the same mechanism, I would suggest. Yeah. So with that, I'll just stop. But clearly there are effects, and some of these effects are obtained at very low levels. But I don't know that we know the molecular mechanisms.
Some comments? So it's funny because what you mentioned, BPS being only around 10% free and being at the level of 0.2 to 1 nanomolar, that's what androgen and estrogen are. They have a very high affinity, they work at the low nanomolar range, and only 4 to 5% are free in the serum. So it fits the profiles of being able to activate a possible estrogen receptor. It fits the profile of a behaving like an hormone. The other thing also I wanted to add is it's very complicated for estrogenic compounds because it's not only the classical estrogen receptor alpha and beta, as you know, but it's also the plasma membrane GPR, so or GPR30, the way you want to call it, which is a totally different mechanism of action where it binds estrogenic compound is going to induce the cyclic AMP cascade, like a very different from the estrogen receptor, which are nuclear receptor that are transcription factor themselves. This one is not a transcription factor. It's involved in very short action, as you know. And there's also the ERR receptors, alpha and beta, which are, and now there's a new gamma. So potentially that BPS can bind a number of these receptors. BPS has been shown to bind these receptors. But it's not only that. To make it more complicated, they have different affinity for SSBG, the protein in the blood that binds androgen and estrogen. So if it has more or less affinity for the carrier protein in the blood, it's going to change the availability of the free BPS, to act on a receptor. And also, they have been shown all these chemicals, at least for BPA and genistein and other estrogenic compounds, that they do act also as an activator or a repressor in the transcriptional machinery in the nucleus. So, and we've seen example where you measure your genistein or your BPA totally in vitro binding on the receptor. You see it's 1,000 times less efficient at estradiol, and you put it on your cell, and it's actually acting at 10-12 or 10-9 molar, much more efficiently in the cell setting with a real cell with all its lipids and proteins and so on. Very different from binding on an isolated receptor. So we don't know yet, but the profile you give us would suggest that it could actually act as an estrogenic compound. Basically, it has the right profile, let's say. So maybe they tested a bit higher, higher micromolar range. And we don't know because they used the doses. They didn't measure the concentration in the blood, unfortunately. But I think it has potential to, with more studies, we start to realize that it's probably similar to BPA in behavior. And that diphasic effect is also typical of the endocrine system. You have a different effect at low dose and high dose, the non-monotonic. It sort of fit this endocrine disruptor and behavior and profile, I think.
I agree. I just don't know if I agree about whether BPS or BPA, which have a log P of about 1.8, can adequately compete with estrogen or estradiol with a PK, a log P, of, orders of magnitude more lipophilic. And that's a requirement, even for the GP receptor, the estrogen receptor. So I agree that one of the reasons you have to push the concentration so high is if that is the mechanism, is to force the mechanism. The question is, does that ever occur in a real life situation? And I think that's a really important question that needs to be answered. But there is a paradox there.
Patrick.
Yeah, thank you for those comments. I mean, that is such an important question, right? And maybe I shouldn't have just pushed the dose away altogether, but I didn't altogether. But yeah, I mean, I'm looking at the data from the NTP report, and yes, you have to be in the tens of micromolars for BPS to actually act as an ER agonist, and this is higher than any of the other bisphenols, and definitely, like 3 orders of magnitude higher or more than estradiol. So yes, in terms of well-defined mechanism of action, I think the clearest one, the most logical one that people have investigated is this binding of bisphenol to the estrogen receptors, and that's happening at a much higher concentration. But what I noted last year, and those are not necessarily repro studies, but what's really fascinating is when people have actually done really in-depth transcriptomics comparing BPS to other bisphenols and estradiol, what people have seen is that the transcriptional responses are happening at low doses and are very, very different from each other. So what that suggests to me is that there's one mechanism that we know of, yes, that's operating at higher doses than any other bisphenols, or most of the bisphenols, and definitely than estradiol. But there's definitely something else that BPS can do to the cell that might not be mediated by the ER, agonistic activity here. That's happening at a lower doses. And so we don't have necessarily a clear understanding of what's happening there, but something is happening at lower doses. And in some of the studies listed, including on that spermatocyte cell line, the GC2, people have tested and seen like mitochondrial responses in like 10 to the minus 10. So there is a low dose effect that's there. That's more on the mode versus mechanism. And I agree that it would have been beautiful to align all this together, but we can't. But it's not negating any sort of low dose effect of BPS at environmental levels.
So when you were speaking about 1000-fold, you were speaking about the in vitro receptor binding or luciferase like receptor activity, because these are not. If they were in cells, will be more valid. But if it's just the pure receptor binding,
what I was talking about,
yeah, where you were saying.
So there's a collection. I would have to actually go to the actual data set here to look at the different assays that were used. But the NTP has a collection of both biochemical assays as well as reporter assays. And I believe it's the collection of them that gave them that estrogenic agonist activity. 1000. Which is, at like in the tens of micromolars. But yeah, it's not just a biochemical receptor thing.
Yeah, and the luciferase of a receptor, the reporter assay, it's fine because it's in a cell at least. So you have the environment of a cell. So
just to make it more interesting, none of those assays include serum protein in the assay. They're serum free. So yeah.
How for your mechanism, as you think of it as binding into receptors, we're looking at receptors in at least 2 different populations here. We're looking at the ones that, like the Leydig cell, that's going to generate the estrogens, and then we're looking at the receptor cells that are going to respond. And I'm wondering, is there any way to look, if that's the mechanism as receptors, is there a way to establish what the binding activity is in both sites? Because what the long-term measurement at the end is what the germinal cells respond, right? That's how you decide that's how you decide whether that's the mechanism. But that could be blocking something at some point and not actually affecting the steroids at all. And another point, it could be blocking the steroid effect and not having anything to do with what's going on. I'm just curious, just trying to figure, how do you balance out 2 different receptor sites, and one of them is a mechanism you're using to figure out whether there's a response, and the other is the response of the other cells. Does this affect, say, for instance, and I don't know a lot about endocrinology, but does it bind the protein, the receptors? I believe that the receptors that are on the cell types that generate estrogens, as an example, that changes their ability to, that their response, right, and generating it. It doesn't have anything to do with the sites that are going to be affected. So I'm just kind of curious, is it, is it the receptor is the estrogen going down because of this? Maybe that's that three-phase thing we're looking at. Is one is blocking the receptor site, and the other is blocking both. And then you can't overdo it. I don't know. I'm just trying to.
You just outlined a 5-year grant.
To make things more complicated, the germ cell, most of them have aromatase. So they can actually take the testosterone, the androgen that has diffused inside the seminiferous tubule, and make their own estrogens, and the Sertoli cells too. So the estrogen don't come only from the Leydig cells, they come also from the and it's really fascinating and complicated. It's not all, when you take spermatogenesis, the estrogen receptors are not going to be, or the aromatase are not going to be expressed at the same level in all these different, subpopulation of cells. So it's very complicated. So.
Additional questions or comments? All right. Then what I'd like to do now then is to turn to our public comments on the agenda for BPS. So Kiana, are you going to share slides with instructions on providing public comment? There they are. Okay, so as a reminder, if there's a member of the public here in person or anyone who wants to make an oral comment at today's meeting, to please fill out a blue comment card. These are located in the back of the room, and we'll be calling on those present in person to provide public comments first. Do we have any comment cards? No? Okay. Then for those of us who are joining virtually and want to make an oral comment at today's meeting, please, then I assume you're on the Zoom webinar, and if you'd like to make a public comment, you can click on the raise hand icon to indicate you would like to speak. Do we have any members of the public who would like to comment via Zoom? No? All right. So then looks like having no public comments, either in person or on Zoom. Then I would like to see if there are any additional clarifying questions from any of the committee members. No, I think we've had a very active discussion already. Is there anyone else wishing to provide public comment? One last chance. All right. And then seeing none, then I'll now turn over to OEHA staff and ask if they have any clarifying comments to add.
We don't have additional comment at this time.
All right.
Thank you.
All right. So there's, okay, before we vote, I just wanted to say that this is the last opportunity for the committee to discuss this agenda item before the vote. So if anyone feels that we should delay the vote to have more discussion, not seeing that, then I think we can, I can ask, is everyone ready to vote? Yes. All right. So I also wanted to note that this vote does not change the existing listing of bisphenol S for female reproductive toxicity. So that has already happened. And now I need to, I'm going to, sorry, I'm on page. So these are the specific questions before the committee. So first, has bisphenol S been clearly shown through scientifically valid testing according to generally accepted principles to cause reproductive toxicity based on male reproductive toxicity? So if all of those voting yes, please raise your hand, and we can do this by a show of hands today. Let's see, 9, I think I counted, right? Yes, all right. So all those raising no, saying no, raise your hands. I see no raised hands for no, and I don't see any abstentions since everyone did vote. So we have 9 yes votes, 0 no votes, and 0 abstentions. And so then Tina, I think, is tallying the vote. All right. Okay. All right. And you'll provide the summary to Dave for committee action, right? Yes. Okay. So we have a break scheduled, but since we had a long lunch break, I think we can probably move forward with the staff updates. Is that acceptable for everyone? Okay. All right. So the next item on this agenda is the staff updates on Proposition 65 listings, regulations, and litigation that have taken place since our last meeting. So, Kiana? Do we have the listings?
Hello, everyone. All right, thank you, Dr. Luderer. I'll be providing you with an update on important Proposition 65 developments since the last DARTIC committee meeting. I'll start by going over the chemicals or endpoints added to the Proposition 65 list or under consideration for potential listing. Then I'll review the proposed safe harbor levels in Section 27,000 update. After that, I'll turn it over to our counsel, Christy Morioka, to provide a brief update on other regulatory actions. Perfect. Following the committee's last meeting, bisphenol S was added to the Proposition 65 list as a reproductive toxicant for the female reproductive endpoint. BPS remains under consideration for listing as causing developmental reproductive toxicity. Information from the BPS data call-in will be used in preparation of a hazard identification document for a future DARTIC meeting on the developmental toxicity endpoint. Additionally, OEHA issued a data call-in on vinyl acetate to solicit information related to its carcinogenicity. This information has been used in the preparation of a hazard identification document for consideration by the Carcinogen Identification Committee next week on December 19th. And recently, OEHA issued a data call-in on N-methyl N-formylhydrazine to solicit information related to its carcinogenicity. The comment period ends January 10th, 2025. Since the committee's last meeting, we proposed to adopt a no significant risk level for exposure to titanium dioxide, airborne unbound particles of respirable size, where both of the following intake levels must be met. 440 micrograms per day for airborne unbound titanium dioxide particles with diameters of 10 micrometers or less, and 44 micrograms per day for airborne unbound titanium dioxide particles with diameters of 0.8 micrometers or less. We are still in the regulatory process for this proposal. For Section 27,000, there are no additional changes proposed to be made to the Section 27,000 list since the committee last met. Now I will turn things over to Christy.
Thank you, Kiana. Next slide. Oh, there you go. So other Proposition 65 regulatory actions. So at the last year's meeting, we told you about regulations that provided safe harbors for acrylamide exposures in some cooked foods. And this year in October of 2024, OEHA finalized regulations to provide an additional, more general safe harbor warning option for businesses that cause significant exposure to acrylamide from food products. And last year, we also told you about a proposed rulemaking that added new sections to the safe harbor warning regulations. And this year, we are pleased to report that last week, OEHA finalized those regulations. They amended sections 25.601, 602, 603, and 607.2, and added new sections 25.607.50 through 607.53 to Title 27 of the California Code of Regulations. These regulations make short form warnings more informative to consumers by requiring at least one chemical name in a short form warning. So instead of just saying warning reproductive harm, the short form warning will say something like warning can expose you to N-methylpyrrolidone, a reproductive toxicant. See the Prop 65 warnings website. The regulation also provides additional warning content options for businesses to select from, and provides businesses that currently rely on the existing short form warnings 3 years to transition to the new short form content. The regulations make explicit that short form warnings may be used to provide safe harbor warnings for food products, and they also provide a 60-day transition period during the 3-year implementation period for online retailers to update short form warnings online after notice from a manufacturer. The regulations also codified new tailored safe harbor warnings for passenger or off-highway motor vehicle parts and recreational marine vessel parts. The effective date for the regulations are January 1st, 2025. Next slide. And significant Proposition 65 litigation. The safe harbor warning for acrylamide in food is relevant to ongoing litigation. California Chamber of Commerce versus Bonta involves a First Amendment challenge. There is a preliminary injunction in place which prevents enforcement of the warning requirement for acrylamide in food. The Chamber of Commerce has filed a summary judgment motion, which if successful, would result in a permanent injunction. The hearing for that motion is scheduled for January 23rd. The second case is in the personal care products versus Bonta, filed in September of 2023. The Personal Care Products Council filed a First Amendment challenge to warnings for titanium dioxide, airborne unbound particles of respirable size for cosmetic and personal care products. A temporary injunction is also in place in that case, and a summary judgment motion has been filed. There is no hearing date for the motion, so the court could rule at any time. Outside of the Proposition 65 context, businesses are challenging government mandated disclosures in a number of different contexts. In the Ninth Circuit and elsewhere, arguing that companies' First Amendment rights are being violated because government mandated disclosures are compelled speech. It is possible that the ability of the state of California to require Prop 65 warnings may eventually be affected by court decisions which address disclosures other than Prop 65 warnings. And finally, Physicians Committee for Responsible Medicine versus Newsom is a challenge to the decision not to list processed meats as a carcinogen. So this case is still pending in Sacramento Superior Court, but I don't have any significant developments to report. So thank you for your time. Does anybody have any questions regarding this? Yes.
I understand the value in looking at a chemical from different kinds of endpoints, but you just meant it was mentioned that BPS could be considered yet for a third kind of endpoint, and there's so many other bisphenols that could be considered. Some of them having a lot more activity, biological activity than BPS. I mean, I know we're not supposed to the function of the committee is not necessarily to discuss what's being considered, but I'm just wondering whether it makes sense, since we don't review that many chemicals every year, whether it makes sense to keep on investing in the same one as opposed to look at a wider spectrum or different sets of chemicals that perhaps are more concerning from a biological activity standpoint.
We appreciate the comment for sure. And I would say that that is a comment that we'll take back and discuss internally. I do hear you that there are, that the committee may have other input, and that is potentially something to talk about in the future. So we will talk about that. And Martha may have other things to add.
Yes, thank you. Thank you for that comment. And we would entertain and welcome suggestions for other bisphenols that you think we should be looking at. I will say much of the work is already done, and there's a lot of, just like the data sets for female reproductive toxicity and male reproductive toxicity, there's robust data sets for developmental, and that may be useful when looking at other related structures, other bisphenols, but thank you.
Okay, thank you. Any other, Martine, yes?
I was puzzled by the processed meat, like physician committee for responsible medicine versus Newsom for processed meat. I mean, there's so many different things in processed meat. How can you categorize the processed meat as one general toxic substance?
I believe that that is one of the main issues in the decision to not list it and also in the litigation. Yes.
But they want it to be listed. So it's the physician committee for responsible medicine that asked for the processed meat to be listed as carcinogenic?
Well, that is challenging the decision to not list it as a carcinogen, correct? Yes, and I'm happy to send you some of the case information if you would like to.
Yeah, I don't know how they can build a case actually.
Thank you
for
for
a broad topic.
Thank you for the question.
Now I'd like to ask Dr. Krishnan to summarize the actions of the committee.
I have the tally, official tally from Tina. Thank you. So the committee has voted for the question. I'll reread the question and then, should I?
Sure. Oh, would you like me to reread the question? Oh, sorry. Right,
Has bisphenol S been clearly shown through scientifically valid testing according to generally accepted principles to cause reproductive toxicity based on male reproductive toxicity? And the DARTIC members votes come to 9 yes, 0 no, 0 abstain. 0 abstention. Okay. So number of yes, number of. So 9 S votes to add BPS to the list, to list
yes.
BPS as the male reproductive toxicant.
Thank you very much. And with that, I will adjourn the meeting and thank everyone, all the presentations from the staff and all the great discussion and presentations from the panel members as well. Thanks, everyone.
Thank you all, the committee.